first of all, let's see if we can review from Algebra 2. All right, Algebra 1 as well, but Algebra 2 in particular. All right, do we remember that if we had a less than or equal to sign or a less than equal sign, less than inequality sign, or a less than or equal to, then we were dealing with what we called and graphs because they were compound graphs. Do we remember this? And if we had greater than or equal to, then those were or graphs. All right, and you probably just memorized it that way. If you need a mnemonic, greater, right? Greater than. If you emphasize greater than, then you can get an or out of there. If you do less than and you emphasize the and, you get an and in there if you need to memorize it that way, if you need a mnemonic to memorize it. All right, when we graphed these, all right, what? Our or graphs on a number line looked like what? Maybe a number here and a number here, either open or closed dot, okay, depending on the symbol. So we'll put a closed dot here, shaded maybe to the left, maybe an open dot here, and then maybe shaded to the right. Okay, what? Because when we shade, what? We're shading where the solutions are, so our answer is either going to be here or it's going to be over here. All right, that's kind of how you look at it pictorially. The answers are either here or they're over here. All right, they could have both been open, they could have both been solid. All right, your and graphs were compound inequalities. All right, so again, you would have had two different numbers on there. Again, could have been open dots, closed dots, one of each, whatever. All right, let's say they were both closed dots, but on an and graph, we're shaded in the middle. All right, because what? Maybe say x is greater than -1 and x is less than 6, which means it has to be in the middle. So it's a compound inequality with and. All right, so basically those were your two graphs. All right, now if we kind of also, could I change this to interval notation? And instead of having closed dot and open dots, could I have curvy brackets and square brackets, and it's going to be the same thing? All right, so this one with an interval notation would be what? A square bracket right here, and then shaded to the left. And then a curvy bracket here, and shaded to the right. All right, so we've introduced interval notation. So if I put my interval notation on my number line, all right, we've done those. It's the exact same thing. All right, square brackets correspond to the closed dot. Curvy bracket corresponds to that open dot. And then what? When it's open, that means the point is not included in the solution. And when it's solid, it is included. All right, if I did it down here, my square brackets would be pointing towards the inside because that's where I'm shading. And then I would clearly shade in the center. If you have to ever draw these by hand, all right, I know Math Excel, you don't have to draw them by hand, okay? Go formative, you don't have to. All right, but if we were to do this on paper pencil, all right, notice how I shaded on the number line, not above it. All right, so don't like number it down here and put solid dots and draw it above. All right, do it right on top of the number line. Do it just like that. Okay, so different people do it different ways. So, all right, so that should have been all review from Algebra 2. All right, now just some new terminology. All right, and the only reason I want to introduce the new terminology, you're not really going to necessarily need a lot unless they would happen to throw something in on the directions. Put some, wordy directions. They've got some new vocab in there, and if you didn't know what those vocabulary words meant, then you wouldn't even know what it was asking for. So, if it's got the equal to part, less than or equal to, greater than or equal to, all right, equal to part means, or another way to phrase this is it is not strict. All right, new terminology that is being introduced into your book. Okay, so it means the exact same thing. We're still going to include the values because it's got the equal to part. So that means you would have your square brackets, all right, or you would have closed dots on either end, whatever, okay, because it's got the equal to part. But your book refers to this as not strict. All right, if it's a less than or greater than, they refer to this as strict. All right, the values are not included. So if we were doing our interval notation, we would be using our curly brackets. If we were doing the open and closed dot thing, we'd be having the open dots. All right, so just the not strict and strict. So if you see that, that's what they're referring to. All right, the problem is not strict or it's strict. All right, now let's just go about solving this. Okay, now we are going to do an algebraic method to solve these. Okay, but I want to also get you to understand if you can do it algebraically, you can do it pictorially. All right, from a graph. Okay, and that's what we're going to rely on to know what we're looking for here. Okay, so let's see. Directions are probably going to say solve algebraically. And then it might say verify graphically. So we're going to take our graphical approach and we're going to hopefully conceptually understand why and what we're even doing with these things. Okay, so solve it algebraically, but we're going to verify it graphically. So what they're going to do is they're going to give you a nice little quadratic, things that we have seen before. So x squared plus 6x minus 16, and then it might say greater than 0. All right, now for today, all right, that's a greater sign, so this is definitely an or. So that right there should tell you what your graph's going to look like. It'll be shaded on the outside. All right, it is also with the new terminology referred to as strict. Okay, now, big picture here, this question, let's get rid of all that bleed through. This question is asking you, where is this quadratic above the x-axis? That's what that means. This whole entire thing is we know it's a what? Upright parabola. Okay, because we know it's positive leading coefficient. It's x squared, it's parabola. So where is this parabola above the x-axis? That's what the question is asking for. So when we solve it, that's what we're solving for. So our answer is going to be an interval notation. Okay, now let's do our graphical representation. Now technically, could I do negative b over 2a and then find the vertex, and then the vertex would be somewhere, all right, and then it's going to be an upright parabola? I mean, I could do all that work if I was going to graph this by hand. I could also what? Get my graphing calculator, put that in, and then it's going to show me where my graph is. Okay, but I'm going to guess somewhere. Let's say that the vertex is somewhere, let's say right in here. All right, so if it's an upright parabola, what's going to happen? It's going to, let's try to do this. Go through the vertex. Okay, sad parabola, but we get the idea. Now the question is, where is the parabola above the x-axis? Well, it's above the x-axis here, and it's above the x-axis here. So what? Negative infinity is all the way down here. Positive infinity is all the way down here, right? So there's a section here from negative infinity to whatever this number is, and then a union, whatever this number is, all the way to positive infinity, right? There's my two parts of my interval notation. Now the thing is, I just got to find these 2 points. Well, what are these points? These points are the zeros of the function. All right, so in other words, I got to solve it, right? So let's just solve it the way we always have. So x squared plus 6x minus 16. Let's go ahead and put equals 0 because I'm just trying to solve it now because I just want to find those 2 points. All right, now, yes, I could use quadratic formula. You don't want to do quadratic formula if we don't have to. If it factors, we want to do factoring. 8 and 2. Can we factor this? 8 and 2, I think we can. I need an x and an x. 8 times 2 is 16. If I've got unlike signs for my negative 16 and the 6 is positive, a plus on the 8 and a negative on the 2. This is why factoring in Algebra 2 was so important, because if you can't factor this darn thing, then you can't solve it. And if you can't solve it, then you can't find those little zeros right there. Okay? And then what? We're doing the zero product principle, so then we set this equal to 0. That tells us x equals 2. And we set this one equal to 0, and that tells us x equals negative 8. All right, so what? That tells me that this number right here is a negative 8. This number right here is a 2. All right, I need interval notation for my final answer. My final answer is going to be an interval notation, so I need this portion and I need this portion. So this is from negative infinity to negative 8. I'm going to go ahead and write interval notation. So negative infinity to negative 8. Union. It's supposed to be an 8 right there. And now I need this section over here, 2, all the way up to positive infinity. Now, I said it's an or. This is what the answer is in interval notation. There is a corresponding number line. It should be an or number line. Do I have two parts? Would these two parts be shaded on the outside of the number line? They would. If I were to do this on a number line, my negative 8 would be here. My 2 would be here. All right, now, what type do I have open? Well, if we do open dot, close dot. Let's do curvy brackets, square brackets. Do I need curvy brackets or square brackets? Curvy brackets because of this right here. All right, so curvy brackets here. All right, curvy brackets. Okay, so curvy bracket here, shaded over here. Curvy bracket here, shaded here. All right, which is an or graph. We could also do open dots here as along with the curviness. That corresponds to your interval notation. You've solved it because what? It was asking where is the parabola above the x-axis. If I switch that sign right there, I could say where's the parabola below the x-axis. Okay, and this is why in this chapter, they're always going to be quadratics, but in the next chapter, this could be a rational function. This could be a square root function. It could be an x to the third. It could be an x to the fourth. All right, so lots of places where it's going to be above and below the x-axis. All right, now, this one, everything was already on the left-hand side. All right, we already had 0 over here. So this one, that type, you can just start solving it, figuring out where those 2 points are, and then figuring out whether it's above or below, okay? If there's something on both sides, then you've got to change your inequality before you can start solving. So let's do another one. Let's do like an x squared is less than or equal to 4x. Okay, I can't solve that one right away. Why? Because I don't have 0 on the right-hand side. So you need to choose to move everything to one side or the other. I would recommend moving everything to the left. All right, but you wouldn't have to do it that way. Move all terms left. So what? We're going to subtract 4x from both sides of the equation. So make it an x squared minus 4x. And then less than or equal to 0. I just moved everything over to the side so that I could start to work with this, solve it, that sort of thing. All right, now if we're going to identify some things, then what? This is a less than. All right, so that means it's going to be an and graph, which means everything's going to be in the center. Okay, not on the outside, on the inside. All right, and it also, with the new terminology, it's not strict. But this time, where is this parabola below the x-axis? That's what the question is asking for. Where is it below the x-axis? All right, so again, if I do the sketch first, because I just want to think about it, what do we know about this quadratic? Well, it's positive leading coefficient, so it's going to be upright. I don't have to be really precise, although I am going to be kind of precise because I can look at this ahead and kind of know where my 2 zeros are. Okay, so I'm going to have something like that. I went through here on purpose because I looked ahead and knew what one of my zeros was going to be. All right, but where is it below? Where is this parabola below the x-axis? That's what it's asking for. Well, here's the parabola, and then where is it below? It's below right here. which it corresponds to what? Corresponds to an and graph, so everything's in the center. You're only going to have one little thing of interval notation, and it's going to be this right here. But again, the question is, we need to find this point, we need to find this point, we need those zeros of that function. Okay, so x squared minus 4x equals 0. I'm just equals 0 because I'm trying to find the zeros. Factor out an x. That'd be the easiest way. Again, if you wanted, you could do quadratic formula. We don't want to do that if we don't have to. Factor out an x. So then I'm going to have an x minus a 4. All right, zero product principle. Set everything equal to 0. X equals 0. X equals 4. All right, so yes, I looked ahead, so I kind of knew. I knew this one was going to be a 0, and this is going to be a 4. All right, if I do the number line first, I could do the number line first. Let's do the number line right here. It's going to be an and graph. I'll have a 0 here. I'll have a 4 here. Now, how do I know whether it's going to be solid or open dots or curvy square brackets? I look at the inequality symbol. It's got the equal to part. Because it's got the equal to part, then I have to include the closed dots if I'm doing closed dots, or my square brackets. I know it's an and, so I know I'm shading in the center. So my numbered line is going to look like that. If you can do the number line, then you can do the interval notation as well. I'll put it in a different color, because whatever your number line looks like should correspond to your interval notation. So square bracket, 0 to 4, square bracket. This is the solution. This right here is the solution, because I don't have just one number that fits. I have sections of the graph that is my answer.